So, lesson 2.2, factor theorem and synthetic division. So let's start with synthetic division. So our last lesson we did dividing polynomials using a long form of division. I'm going to show you a quicker way to divide a polynomial with a divisor of the form x minus b, a linear factor, where b is a constant value. So recall, the dividend is the number or expression you are dividing into, and the divisor is a number or expression you are dividing by. Okay, and we're going to follow these steps to apply to divide a polynomial by that divisor x minus b. Okay, and there are two approaches to this one. Your textbook approach is written here, but I'll go through maybe a more intuitive approach, especially for my AP students who may have seen this in previous years. We'll stick to that approach for synthetic division. So steps for synthetic division. Number one, write the b and the coefficients of the dividend in descending order in the first row. Okay, if x terms are missing, place a 0 in its place. Step two, bring the leading coefficient to the top row down to the bottom third row. And step three, next, multiply the first number in the bottom row by your value of b and place this product in the second row under the next coefficient and subtract these two terms together. Step four, continue this process until you reach the last column. Step five, the number in the bottom row are the coefficients of the quotient and the remainder. The quotient will have 1 degree less than the dividend. So as I read these steps, hard to visualize, but we'll get into an example of what that will look like. So let's get into an example right now. Here you go. Use synthetic division to find each quotient. So step one, we are going to, well, let's create first this little chart. Okay, and step one says we're going to write these coefficients of our polynomial in descending order by the term, degree of the term, and we're going to place that in our chart. And if there's any x terms missing, we're going to replace it with a 0. So here we have a cubic polynomial starting with a leading coefficient of 5. Then we have a minus 6x squared, so I'll write a minus 6. Then we have a plus 3x, so we write a 3, and then we have a 14. Okay. And we are going to write down the value b. So we're dividing by x plus 1. Where we're going to be putting here on the side is a minus 1. Right, so think about that. If we have x, if we're dividing by x minus b, and x minus b is equal to x plus 1. So what is the value of b here? B is then minus 1. Okay. So what's step two? Step two, bring the leading coefficient in the top row down to the bottom. So we have a second row here that's blank. So we're going to bring this down, past the second row down to the bottom. Let's call up the third row. Okay. We're going to multiply. Step three says we're going to multiply the first number in the bottom row, that 5 there, with b, or multiply it by b, and place this product in the second row under the next coefficient. Okay. So -1 times 5 is -5. Okay. And instead of subtracting, like I said in the instructions, your textbook will subtract. And your textbook, first of all, will use a +1 instead of a -1. So if you're going to use a -1 here, we're going to do an addition instead of a subtraction. So -6 plus -5 is -11. Okay. So that 5. So that -11 goes down to the third row, and you take that -11 and again multiply it by b. -1 times -11 is +11, and that goes up into the next column under the next coefficient in your second row. Okay, the 3 and the 11 get added together, so 3 plus 11 is 14. And then -1 times 14 is -14. And then 14 plus -14 is 0. So this is step 4. We're just continuing that whole process until we reach that last column. And step 5, the number in the bottom row are the number, well, all these numbers here are the coefficients of the quotient, and with the last number there at the end is the remainder. Okay, so 5 serves as the coefficient of x squared, minus 11 is the coefficient for x, and the 14 is your constant term, and the remainder is 0. Okay, how do I know it's x squared? Because I'm dividing an x cubed by a linear factor, so the next degree down would be a quadratic, so I would expect my quotient to be a quadratic. Okay, so that's the quotient. And some questions further on, we could probably further factor the quadratic to get all the possible factors. But here, this question, we're just stopping there. Okay, so back up to our notes. Okay, so instead of subtract, we're going to use add. Your textbook will say subtract. We're going to use add. And this may have been something you've seen before, perhaps. And just remember the what you're using in the synthetic division is b, okay? So if it's divided by x minus b, you're going to have to kind of change the sign, okay, and make it b. All right. Next, factor theorem. If x minus b is a factor of the polynomial of p of x, then p of b equals 0. So if p of b equals 0, x minus b is a factor. Kind of like remainder theorem, right? If you plug in that value of b, you get a remainder. But if your remainder is 0, then you know x minus b is a factor. Okay. Similarly, if you now have a coefficient in front of x, if ax minus b is a factor of the polynomial function, then p of b over a equals 0. Or if p of b equals 0, therefore x minus b over a becomes ax minus b, which is a factor. Okay, so that's a factor theorem. It's just a way to tell us that is what we're dividing going to lead us to factors of that polynomial. Okay, and you want factors, you don't want, so that you can find factored form of a polynomial without any remainders at all. So that's really the crux of this lesson, how to divide using synthetic division and factor theorem. Summarizing other things like the remainder theorem, remember if the polynomial is divided by x minus b, then the remainder is p of b. So if you're dividing a polynomial, let's say by x minus 1, here's this polynomial, we're divided by x minus 1. So you plug in a 1, a positive 1, okay, right? So x minus b equals x minus 1. So what is b? B equals 1. And so p of 1 is my remainder, and that turns out to be 2. Okay, you get a remainder of 2. If, however, you're using something like factor theorem, the difference between the two is apparent here. If b is 0, right, if this value of b turns out to be an x-intercept or a root, then that polynomial has to evaluate to 0, right? The y value is 0 at the x-intercept, right, or at the root. So x minus b is a factor. So in that case, if I'm dividing by x minus b, in this case, let's divide by x plus 2 in this example. Here's your polynomial p of x. We're going to divide it by x plus 2. So if x minus b is x plus 2, then what is b? Well, b is minus 2. So that goes into your polynomial. Evaluate it. Hey, it says 0. We've just found ourselves a 0. Negative 2 is a root. It's an x-intercept. So that means x minus 2 must be a factor. Okay. So that's a really useful tool for us moving forward. And one more theorem here, irrational zero theorem. When the leading coefficient is not 1, ax minus b is a factor of p of x, where x equals b over a. So possible factors for the dividend come from factors of b and factors of a. Okay, so let's go through some more examples. Let's go to example b. What if I'm going to divide this? So back to synthetic division, essentially. Let's divide up another polynomial by x minus 3. Okay, and so here I'm going to draw my chart. I'm going to use a ruler this time. Perhaps it might be a little bit more neater. Here's my chart. like an L shape. Then we're going to write down the coefficients of the polynomial, make sure they are in order. So x to the power 4 is the highest degree. We're going to put the coefficient for that one first, so 2. Then the -8 for the x cubed term, and then the +5 for the x squared term, and then our constant. Well, oh, we are missing an x term. Okay, so we're going to put a 0 for that missing x, and then a 4 for that constant at the end. Okay, so unlike the last one we did, we had a cube, a quadratic, and an x, and a constant. We're missing no terms there. Here we have a x to the 4, x cubed, x squared. I need an x term, so I have to put in a 0 for that, and then a constant term 4 at the end. We're dividing by x minus 3, so here on my side, I'm going to put a 3. Okay, and that's step 1, writing out all those numbers. Step 2 says it's bring down the 2, skip the second row, bring it down to the third row. Multiply like that 2 with the 3 there, so 3 times 2 is 6. Bring that up to the second column under the second coefficient in the second row. And then you add. Okay, so that's the key thing here. We're going to add. So -8 plus 6 is -2. Put that in the third row. And then take the -2, multiply it by your, let's call it our divisor again. So 3 times -2 is -6. All right. And then we bring that to the second row again, onto the next coefficient there. Add those two numbers together. 5 plus -6 is -1. Write that in the third row. Right, multiply the -1 by 3. That's a -3. Write that in the second row on the next column. Add the 0 and the -3, you get -3. And then -3 times 3 is -9. When I add 4 and -9, I get a -5. Okay. And so your remainder may not be 0, right? So we have a remainder here of -5. And my quotient here is, well, if I have 4 numbers here remaining, and I'm dividing a quartic function by a linear factor, my result should be a cubic, 1 degree less, right? 1 degree less. So it's going to be 2, the first number is 2, x cubed, then a -2, x squared, then a -1x, and then -3. And that's my quotient with the remainder of -5. Okay. So in quotient, so that's my remainder. Remainder equals -5. There we go. Let's try another one. Part C. Actually, before I go there, let's just make sure we properly, when we do these kinds of questions, we want to do writing the proper form, or quotient form. So if I were to go back to that question again, 2x to the power 4 minus 8x cubed plus 5x squared plus 4, we're dividing it by x minus 3. And so the quotient is 2x cubed minus 2x squared minus 1x minus 3 plus our remainder, or sorry, minus 5 over the divisor x minus 3. Okay, so that's what that proper form looks like. Next, we go to part C. So 2x cubed minus 5x squared minus 23x minus 10 divided by 2x plus 1. And so now we have here this one, this form with the coefficient ax minus b. So let's draw out our chart. Leading coefficients are 2, -5, -23, and -10. There are no missing terms there, so that's fine. And what will be the factor that goes on the side will be? Okay, well, we're going to say it's -1/2. Okay, because why? Because remember, 2x plus 1 equals ax minus b. So what is b? Well, b is a -1, a is 2. Okay, and so if I have to, in synthetic division, I'm going to use b over a, it'll be -1/2. Okay, so down will come 2, put it there, multiply it by -0.5, you get -1. That comes up to the second row. And then you add, don't forget, you're going to add -5 plus -1 is -6. Multiply that by -1/2. So be careful, you're multiplying by fraction here, okay? So two negatives make a positive. We're going to have a 3. Okay, so that comes up there in the second row, the next column. Add the two numbers, -23 and 3, we get -20. Then we multiply -20 by -1/2, and that brings us to +10. Then add -10 and +10, we get 0. So our remainder is 0, and the resulting quotient is going to be 2x squared minus 6x minus 20. And again, I know I'm dividing a cubic polynomial with a linear term, so my quotient should be 1 degree less, which is a quadratic, and that's what we have here, 2x squared minus 6x minus 20. In the proper division statement, we can express that as follows. Write up the cubic polynomial divided by 2x plus 1, and equals our quotient 2x squared minus 6x minus 20. And the fact that our remainder is 0 says that 2x plus 1 is a factor of this polynomial. Okay. So pause the video. I want you to try this question. Okay, so hopefully you had a chance to try it. I'm going to reveal the answer here. Okay, so here it is. This one's a little bit trickier because x to the power 4 minus 16 has so many missing terms. So I have to put in a 0 for each of the cubic, quadratic, and the linear term. And then you carry out the synthetic division steps like I've shown you, and the resulting quotient should be x cubed, 1x cubed, 2x squared, 4x, and 8, with a remainder of 0 if you did the steps correctly. Okay, let's move on to our next page. Number 2, find the quotient and remainder of x cubed plus 8x squared minus 5x minus 84 divided by x plus 5. So another example where we can apply synthetic division to this. Synthetic division to this. So I'm going to draw another chart. I'm going to write up the coefficients. So x cubed is a coefficient of 1. And we have 8 for the x squared term, and a minus 5 for the x term, and then a minus 84 for the last constant term. And make sure you're not missing any factors in between. And then the division by x plus 5 means here on the left side, I'm going to write a minus 5. Okay, bringing down the 1, that's the third row, multiplied by minus 5, and that's minus 5. You bring that to the second row on the next column. Add the 8 and negative 5 together, we get positive 3. Multiply that by negative 5, you get negative 15. Bring that to the second row on the next column. Negative 5 times plus negative 15, add those together, you get minus 20. Multiplying negative 20 and negative 5 gives you positive 100, which you put on the second row again on the final column. And negative 84 plus 100 is 16. So there, that 16 is our remainder. That last number is always our remainder, whether it's 0 or another number, it's 16 here. And the quotient comes from those three numbers, 1, 3, and negative 20. Okay, so our quotient is x squared minus or plus 3x minus 20, and our remainder is 16 over x plus 5. Okay. So that I'm just separating the two because the question says, hey, let's find the quotient and the remainder, and so there it is. Let's look at example number 3. Determine if x minus 3 is a factor of this polynomial x cubed plus 5x squared minus 17x minus 21. And now we have a unique tool for us to use called the factor theorem. It says, hey, if I took p of b, and that's 0, then we know x minus b is a factor. Okay. So in this case, for x minus 3, we're going to use b equals 3. So we're going to find p of 3. And if you plug in 3 into our polynomial, 3 cubed plus 5 times 3 squared minus 17 times 3 minus 21, and evaluate that, we'll get our answer. Okay, so evaluating each of these terms, we get 27 plus 45 minus 17 times 3 is 51, and then minus 21, and that, yeah, that should turn out to be a 0. So p of 3 equals 0, and since it is equal to 0, we can say therefore x minus 3 is a factor. Okay. Number 4, let's show that x plus 2 is a factor of this polynomial, 2x cubed plus 3x squared minus 8x minus 12, and then factor completely. Okay, so we're going to get into factoring now. All right, so let's show first that this is a factor. So let's say p of -2. We plug that into our polynomial, 2 times -2 cubed plus 3 times -2 squared minus 8 times -2 minus 12. What does that evaluate to? 2 times -2 cubed is -16. 3 times -2 squared is plus 12. And then we have plus 16 and then a minus 12. Oh, that is 0. Okay, so there you go. We've proven that x plus 2 is a factor. Okay, so x plus 2 is a factor by factor theorem. Okay, we discovered that x plus 2 is the x-intercept. It's a root for this polynomial because the polynomial, the y value is 0, essentially. Can we find other factors? And so we can endeavor to find other factors by dividing this polynomial by x plus 2. So 2x cubed plus 3x squared minus 8x minus 12 divided by x plus 2. So we carry out this division to find additional factors, because the quotient could be factorable, right? So let's take our ruler again. Let's create our synthetic division chart. Let's put in our chart the leading coefficients. So we have 2x cubed, 3x squared, minus 8x, and then minus 12. And then we have a minus 2 as our divisor on the side. Then we carry out the steps again, bring down the 2 to the third row, multiply by -2, we get -4, bring that to second row in the next column. 3 plus -4, when you add these numbers up, we get -1. Multiply that -1 by -2, we get +2, and put that in the second row in the next column. And then add the -8 and 2, we get -6. That in the third row. -6 times -2 is +12. Bring that to the second row in the next column. And then finally, -12 plus 12 is 0. Okay. And because x plus 2 is a factor, we expect that the remainder, this should be 0, right? Because we proved that by the factor theorem. There is no remainder. Okay. And so if you don't get a 0 in that last column, then you probably made a mistake somewhere in your synthetic division, right? So you have to double check your work there. So here is our quotient, right? So our quotient is 2x squared minus x minus 6. Okay, so what does that say? Well, that says 2x cubed, the whole polynomial from the beginning, 2x cubed plus 3x squared minus 8x minus 12 is equal to x plus 2 times 2x squared minus x minus 6. Okay, so these two factors, when I multiply them, give me that original polynomial. But can I go a step further, right? Well, if you see that, look carefully, 2x squared minus x minus 6 is a quadratic, and that's factorable. In fact, I can take that, use your knowledge of factoring quadratics from your previous grade 10 and grade 11 math classes, and factor that further. So x plus 2 is still one of your factors. You leave that as x plus 2. But 2x squared minus x minus 6 can be further factored as 2x plus 3, and then multiplied by x minus 2. Okay. And so now we have something that's fully factored. I'm just going to write here a note, factor this quadratic. And when you're taking this class with me, I'm not going to be very particular with how you factor a quadratic anymore. You can use decomposition as the kind of traditional method if you like, or if you just can look at a quadratic and you can see its linear factors, then just write down the linear factors. If there are other methods, a crisscross method, box method, that you're comfortable with, I'm okay with that too, as long as you can get that, get those factors there. So there's our fully factored form, and from the fully factored form, you see here, we can have more information about the polynomial. Where are its roots, x-intercepts, okay? And that can help us further in the course when we start doing more complex things with solving equations and graphing. Okay, let's look at another example again. Factor completely. Okay, number 5, x to the power 4 minus x cubed minus 11x squared plus 9x plus 18. And we're not told what factors to use. Okay, so we're going to have to use some thinking here. So what are we going to do in this case? Well, we need to apply factor theorem. Okay, so use factor theorem. Which means we're going to need to find some value of b that gives us a 0. Okay, like that x-intercept. So again, f of b equals 0, and so x minus b is a factor. But what is that value of b? And that needs a little, you think about that in the beginning. Okay, how do I get this polynomial to equal to 0? I need some value of x, and I put it into these first 4 terms, gives me negative 18. And when I add negative 18 with positive 18, I'll get it at 0, right? Because that 18 is going to be fixed there no matter what. There's no x to that term. So I'm going to explore possible factors of 18 to help me get there. Okay, so we're going to use possible factors of 18. So what are some factors of 18? 1, right? 1 times 18. 2 times 9. 3 times 6. Okay. And then so yeah, 6, 9, 18. But not only these positive numbers are factors, but the negative equivalents as well. Plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, plus and minus 18. I could use negative numbers as factors as well. Okay, so we now have some possibilities, right? So we have 12 possibilities here, and we're going to check each one until we find a factor. So we're going to start looking for factors. Okay, so try f of 1. Okay, so f of 1, 1 to the power of 4, minus 1 cubed, minus 11 times 1, plus 9 times 1, plus 18. What does that equal? When you add those terms all up, you get 16. Okay, so that doesn't really help. We didn't get that 0. We wanted a 0. So we can cross that off the list. What about f of negative 1? That might be better. Let's see. Negative 1 to the power of 4 minus negative 1 cubed minus 11 times negative 1 squared. I forgot to put a square there. And then plus 9 times negative 1 and plus 18. So we do this carefully. Negative 1 to the power of 4 is 1. Minus negative 1 cubed is 1. Okay, so those cancel each other out. I have a minus 11 for my next term and then a plus or minus 9. Oh, sorry. Did I make a boo-boo here? Minus 9 plus 18. Does that work out? Yeah. Oh, sure. It should be plus there, actually. Minus, minus, plus. Okay. So 2 minus 11 is minus 9 plus 18. Yep, that looks like it works. So that's going to be a 0. Aha. So now we can say, hey, x plus 1 is a factor. Right? So if I plugged in x equals negative 1, That's the x-intercept, right? So the factor should be x plus 1, right? So x plus 1 is a factor. And so once you discover one of the factors, you don't need to test all the other ones anymore. That's a tedious process. But you can now apply synthetic division to find the other factors. So apply. So therefore, we're going to carry out the synthetic division of x to the power 4 minus x cubed minus 11x squared plus 9x plus 18 divided by x plus 1. Okay, and just don't get confused with the signs, please. Okay, I know I put minus 1 for b, which means x minus b, right? So x minus b equals x minus -1. So that should be x plus 1. That's your factor. Remember, x minus b is the factor. You plug in b, and that satisfies your factor theorem. So the factor we're considering here is x plus 1. Okay, so let's apply synthetic division. Coefficients are 1, minus 1, minus 11, plus 9, and 18. Then a minus 1 goes here on the side. Carry 1 down, multiply 1 and -1, we get -1. Then we add, we get -2, multiply, we get 2. -11 plus 2, we get -9. Multiply, we get +9. 9 times 9 is 18. So 9 plus 9 is 18. Multiply by -1, we get -18. And then 18 plus -18 is 0. And so we get x cubed minus 2x squared minus 9x plus 18 as our quotient. Okay, so far, that's what we've got. X cubed minus 2x squared minus 9x plus 18. Now, we're not done yet. If we're going to be fully factoring this, I'm going to have to carry out another set of steps to finding another factor. Okay, x cubed minus 2x squared minus 9x plus 18. What is a number that satisfies the factor theorem for this? Now, again, look at all the possible factors of 18, which we have up here. Okay. Now we've already concluded that 1 doesn't work, right? So f of 1 not equal to 0. That's not a factor at all of this polynomial, of the original polynomial. So it would not be a factor of this cubic quotient here either. And we already used the -1, so let's move on to 2. So if we tried f of 2, what do we get? We get 2 cubed minus 2 times 2 squared minus 9 times 2 plus 18. That's equal to 0, right? 8 minus 8 minus 9 plus 18. Yeah, okay. Minus 9 times 2 times, yeah, it's 0. That's perfectly okay, good. 0. So that means x minus 2 is another factor. Is a factor. Okay, and then so I can take x minus 2 and then further divide that polynomial. All right, so I should have left more space here, but let's see if we can fit it all in. So x cubed minus 2x squared minus 9x plus 18. Let's put the coefficients of that one down. So 1 minus 2 minus 9 and 18. We're dividing by x minus 2, so it's going to be 2, positive 2 on the left side there. And now we're going to carry out the steps here. So 1 comes down. 2 times 1 is 2. Add it to -2, I get 0. 2 times 0 is 0. Add it to -9, I get -9. -9 times 2 is -18. 18 minus 18 is 0. There we go. And so now I have 1, 0, and -9, which are the coefficients of my quadratic quotient here, x squared plus 0x minus 9. Okay. A little bit messy here toward the end, my apologies, but you can see where we're doing nested synthetic divisions, multi-layered problem here. Okay, so what now? We can start saying, let's go back to the original polynomial, x to the power 4 minus, what was it, x cubed minus 11x squared plus 9x plus 18 equals, what are its factors? Well, we discovered x plus 1 is a factor. okay? We discovered x minus 2 is a factor. So if x minus 2 is a factor of that cubic, it will also be a factor of that original polynomial. So x minus 2. And then the last quotient we found in our second synthetic division was x squared minus 9. And with quadratics, you don't have to do another synthetic division again, but if you can factor x squared minus 9, we know we can recognize that's a difference of squares. We could further factor that as x plus 1, x minus 2, and then x plus 3 times x minus 3. That's your difference of squares formula, if you recall from previous years. So there's our fully factored form of our polynomial here. Okay. Why don't you try number 6? Pause the video and we'll list the answer. All right, so there's your answer there, x minus 1 times 5x minus 2 times x minus 2. If you did not quite get that, then come to class, well, ask me in class, and we can go over the steps step by step again. All right, let's go to our last example, kind of a thinking problem. Determine the value of k so that x minus 3 is a factor of that polynomial x cubed minus 2x squared plus kx minus 6. So for a question like this, you can always go back to factor theorem. So if we're dividing by, if we're trying to say x minus 3 is a factor, then f of 3 is going to be 0, okay? So that means when I plug in f of 3 into this polynomial, I can say here 3 cubed, so x is 3, right? 3 cubed minus 2 times x squared, so 2 times 3 squared, plus k times x, so k times 3, then minus 6, that has to be 0 if x minus 3 is a factor. Okay, and I can just sort of solve this equation for k, right? Let's simplify things. Let's evaluate some of these terms first. So 3 cubed is 27, minus 2 times 3 squared, that's 18. And then I have 3k minus 6 equal to 0. And if I leave 3k on the left side, bring everything over on the right side, 27 minus 18 is 9, minus 6 is 3. So I'm going to have minus 3 on the right side and divide both sides by 3. I get k equals -1. Okay, so the value of k that makes that x minus 3 a factor has to be -1. So therefore, polynomial is x cubed minus 2x squared minus x minus 6 if x minus 3 is a factor. Okay, so that's it for this lesson. Try some of the practice problems in your textbook. There's another you try problem. Actually, you can try this problem right now. Pause the video and I'll post the answer right here just in just a second. Okay, so really it just extends what we've been doing, and we're going to do more equation solving pretty soon. But this just says, hey, if you have a polynomial, oh, I did not, I forgot to make the correction there. So it should be a plus 6. That's a plus 6. Plus 6 equals 0. That equals is still equal. Okay. So if you carried out your steps for polynomial division, factoring, all that, your factored form on the left side should look like this. Okay. And then because it's an equation, we set that polynomial equal to 0. And we can just say, hey, we can solve for the value of x to find these solutions. And you're going to have 3 solutions in this problem, one being -2, and then 1/2, and 3. And these are the 3 values of x that make the equation equal to 0. Okay, so we'll get into more polynomial equation solving in the next lesson. But have a look at the practice problems from your textbook and come to class with questions. See you in the next one.